Welcome to Winsome Mathematics. This is second lecture of gamma function. Beforehand, in the first lecture, we have learned the basic concepts of gamma function and recurrence relation concerning it. Okay. So in this video, we are gonna learn two prominent properties of gamma function, which will help you in tackling all the questions based on these properties. So if you haven't watched, again I am repeating, please check the description. Otherwise, you might suffer. Okay. So all the best and coming to these properties. So first of all, I will define you the first property and the second property. Okay, their importance. Then we will see the proof. Step by step we will proceed. Okay. So without wasting the time, coming to the properties. So we know that gamma n is equal to 0 to infinity e to the power minus x. Very good. X to the power what? I am getting, are you getting n minus 1? Very good. N minus 1 dx. So this was the definition of gamma function. But what's the difference in this definition and this definition? What is the difference? Yes, because this is the difference in the power of e. And what is k here? K is the constant here. Okay, k is not a variable. K is constant here. So something is changing in the power of e. Why is it so? Think, because this is under integration, this is not under multiplication, like this is not like minus k x. Okay, simply, so we can easily write it 1 upon e to the power kx. So here multiplication, this is single term, so we don't have any casualty. Okay, but here this comes under integration, so we cannot just simplify this. Okay, so because this is under integration, the power is changed, so we need to substitute it. Otherwise, we cannot fit it into this definition. Okay, so this is the relevant property, because whenever someone will give you question like this, 0 to infinity e to the power minus 4x x to the power n minus 1 something that like 7 dx. Okay, so how will you tackle this question? You might have problem in this question without knowing the properties, because you will need to do the whole derivation. You will have to fit this question on the definition of gamma function. Otherwise you cannot solve it directly. Okay, so first of all we will convert this into the definition of gamma function, like something e to the power minus y, because we will substitute x, then y to the power n minus 1 something. Okay, after then we can easily write it gamma n, and something whatever we have substituted with will come into denominator or numerator, whatever. Okay, so this was the basic concept, and this and that's why this property is mandatory. Okay, so we need to overcome this problem. So this was the prominent property. And second property, so I will also explain you second property. Second property, you are looking at 0 to infinity and here 0 to 1. Here nothing is about limit, only this is about that something whenever appears in the power of e, you can just put it here. Okay, you can simply write it gamma n. We will find the value of n minus 1, and we will compare the n minus 1, and we will write the value of n under gamma function. Then we will write simply k to the power n. Okay, so we can easily solve this instead of doing all the derivation here, because we cannot solve without the derivation. Okay, so that's why we need to remember this. Now in this property, here 0 to infinity and here 0 to 1. So what is the concept here? Like in beta function, we used to change the limit. Whenever we transform the beta function, we change the limit of beta function. I already told you in beta function that that what is the importance or prominence of the limit. Okay, so whenever question comes in the form of 0 to 1, then the importance of limit enhances. Okay, so that's why we need to study this. Okay, so limit is changing and the terms are reduced in log. Okay, so we will see the derivation of these two properties now. Okay, I hope you got the importance of these two properties. So now we will see the proof of this property, and you don't need to be frightened. Okay, so this is simple, based on I already wrote it. Okay, simply because by simple concept of integration we will solve it. Okay, by simple concept of integration. So first of all, our target is to convert this definition onto the definition of gamma function. Okay, so we will convert this definition whatever is given here. So we will convert this integration basically into the definition of gamma function. Now, first of all, our problem is what? Our problem is the power of k e. Okay, the power of e. We don't wanna watch this k in the power of e. Okay, that's why we will substitute it. Okay, now the first step is putting kx is equal to t. Now you must think that why didn't I put minus kx is equal to t? Because ultimately eventually we need this minus, because this minus always appears in the function of definition of gamma function. Okay, so that's why we need to put merely kx is equal to t. Okay, now we will substitute it. We have substituted, we will see whatever's happening in the limit of integration. Okay, as the limit is lower limit is 0, so whenever x becomes 0, then this term becomes 0, so t will become 0. Lower limit is not changed, and in upper limit when x becomes infinity, then t also becomes infinity, so limit is not changed. Now k dx is equal to dt. Any problem? No, simply we have done the derivative of this x and t. Okay, both sides. Now dx is equal to dt upon k. Now simply we can write 0 to infinity e to the power minus kx, that is t, and x is equal to what? T upon k. So t upon k to the power n minus 1, and dx is equal to dt upon k. And simply we can write it 0 to infinity e to the power minus t, here t to the power n minus 1 and k to the power n minus 1 into dt upon k. And simply now we can write e to the power minus t, t to the power n minus 1 and dt, and this k to the power n minus 1 and k both is in the denominator, so will be multiplied, and this is k to the power 1, so base are same, so power will be add. Okay, power will be added simply. So n minus 1 plus 1, that is 1 upon k to the power n. As k is constant, so we can write it outside the integration. And now this was our motive, and we finally got it. Okay, so this is the definition of gamma n. Okay, so please don't confuse with that is this is tt. Here we used to see e to the power minus x to the power n minus 1, so minus x dx minus t dt. That's why I told you already, please watch the first video, I already discussed it. Okay, so this is the definition of gamma n. Simply gamma n depends on the power of the variable of integration, not on the variable of integration. Gamma n upon k to the power n. So we derived it. Now we will see some examples based on this. I hope you might not suffer any of the steps, okay, included in this integration. Okay, so simply we will see some examples so that we will understand the importance. Okay, now coming to the example. So we will solve all these questions, and we will see how to solve this question based on the properties. So first of all, we will compare this question with the property of gamma function, this property. So what we have to find? First we have to find k, then we have to find n. And how will we find n? We will find n by transforming the power of x in n minus 1. First we will transform the power into n minus 1, then we will put the value of n. Okay, simple. This is the step involved here. So now what can you do? Simply you can compare that k was constant, so here 4 is also constant. The value of k is 4 here. Here the value of k is 3, and here the value of k is also 3, and here the value of k is 3 by 2. Any problem? No. So we can easily write it. So k is equal to 4, put in mind. Okay, now how to write 5? How to write 5 in terms of n minus 1? How can you write it? Simply plus 1 minus 1. Simply do plus 1 minus 1. Okay. So we will do 5 plus 1 minus 1. So you can write it 0 to infinity e to the power minus 4x, x to the power 6 minus 1 dx. So n is equal to 6 and k is equal to 4. Now we can easily write it gamma n upon k to the power n. Gamma 6 upon k to the power n. What is k? 4. 4 to the power what is n? N is 6. Any problem to you? No. And we know that how to solve gamma function. I already discussed in first video that gamma n is equal to n minus 1 factorial. So simply this is 5 factorial 120 upon 4 into 4 6 times. Okay, so we can solve it. Now this question, in this question simply you must solve it before me. Okay, first try to solve it. Okay, simply k is here 3 and here what is n, so plus 1 minus 1, simply do plus 1 minus 1, no need to worry, no need to think. Okay, more, just simply do plus 1 minus 1. So 5 by 2 plus 1, that is 7 by 2, so e to the power minus 3x, x to the power 7 by 2 minus 1 and dx. So this is n and this is k again. So simply what will be the answer? Gamma n upon gamma 7 by 2 upon uh, what is n? 3 to the power 7 by 2. Simple. Okay, gamma 7 by 2 upon 3 to the power 7 by 2. Now how to solve gamma 7 by 2? I already discussed in the previous video, so must watch it. Simply I will tell you gamma 7 by 2 is equal to, first we will write it 1 plus 5 by 2, then we can write it 5 by 2 gamma 5 by 2. Simple, we can easily write it. I already discussed that by recurrence relation n plus 1 is equal to n gamma n. So what is n here? N is 5 by 2. You must remember this relation, okay, because this is more than prominent. I am discussing it again, repeating it again. Gamma n plus 1 is equal to n gamma n, and this I already discussed the importance of this recurrence relation, that it is used to solve fraction in a pinch of time. Okay, simple. So n gamma n, so 7 by 2 can be written as 5 by 2. And why are we writing this? Because our ultimate target is to reach at gamma 1 by 2. Simple. So that is equal to root pi. Okay, so 5 by 2 you can easily write it 5 by 2 into 3 by 2 gamma 3 by 2, and again you can write it 5 by 2 into 3 by 2 into 1 by 2 and gamma 1 by 2, and this is equal to root pi. So gamma 7 is here. So you can write this value and you can substitute it here. Okay, and this 3 to the power 7 by 2 as usual. So this was the technique. Now coming to the third question, and you will see that how strange, what is here, no any power of x. So we will create it ridiculously. Okay, because our motive is to convert it into the definition of gamma function. Simple. So we can write it. How to write? Now think how to write x here deliberately. How to write? Simple, we can write it x to the power 0, because anything raised to power 0 gives you 1. Okay, so e to the power minus 3x and x to the power 0. Simple, any doubt? No. X to the power 0 dx. Now you can write 0 as 0 plus 1 minus 1. Simple. Any problem? No. So 0 plus 1, that is equal to 1. The value of n is 1 here. So 1 minus 1. This is n and this is k. Any problem in it? No. Now you can simply write based on this property. Simple. So what will you write? Yes, very good. Gamma, and that is gamma 1 upon 3 to the power, because this is k and 1. Simple. Any problem? And gamma 1 is equal to 1 and this is equal to 3. Simple. And you can also solve this integration. You will get this simply by using the property of integration, that is, what is minus e to the power 3x upon 3. You can solve it minus e to the power minus 3x upon 3, and you can put the limit 0 to infinity. Simple. Okay, the minus will come outside. This will become again 1 upon 3. When we will put 0, infinity 1 upon, you can easily transform it. I know you can do it. Okay, so simply coming to the fourth question. Now 0 to infinity. Now do it yourself. Must do it. Please, it's my humble request. Do it. K is equal to 3 by 2. Very good. N is equal to 5. Yes, got it. Because 4 plus 1 minus 1. So simply you can write it gamma, and that is gamma 5 upon what? 5 to the power 3 by 2. Any problem? No. So I hope you must understood this property well. Now nothing is more in this property. Now shifting to the other property. Okay. Now I already told you the prominence of this property already. Okay. So now we will see the proof of this property. And our first obstacle is what? That how to solve this question. Now think by the basic concept of integration. And what is our problem? Our problem is to convert this term into the log. Simple. Our problem is to convert this term into log. So somehow we must get log. Okay, so how to think it? So simply we know that e to the power x is equal to 2. Then how will you solve x? You can simply take log both side log e. So x is equal to log e2. So now mind now inside the mind image is clear that now inside the mind image is clear that whenever we take log both side, so here we can get x easily, and here something as a terms of log. Okay, so simply let's put this e to the power minus x as y, so we will see the magic that what happens. Okay, so simply put it. Now simply we know that by differentiating this we get what we get. By differentiating this term we get minus e to the power minus x is equal to dx is equal to dy. Any problem? Here any problem? No, this simple differentiation. Okay. So now 1 upon e to the power x is equal to y. Okay. So how will you find x? Simply y is 1 upon y is equal to e to the power x. Now I know you all are smiling currently. Okay. So simply taking log both side, x is equal to log 1 upon y. Simple. Because taking log this side gives you x. I already told you in the case of e to the power x is equal to 2. Simply x and 1 upon y log 1 upon y. Any problem? No. Okay, so smile. Okay, so smile and solve it easily. Okay, x is equal to log 1 upon y. Now our basic concept is that here limit is changed 0 to 1. So we will see that limit is changing or not. So where can we see it easily? So simply we can get this result from here. 1 upon e to the power x is equal to y. So here when we will put x is equal to 0, then we will get y is equal to 1, because this becomes 1 e to the power 0. So y will become 1, and when we will put x is equal to infinity, then we will get y is equal to 1 upon infinity, that is 0. Simple. So lower limit is infinity, sorry 1, and upper limit is 0. Clear? And now we can write e to the power minus x as y, and x is equal to, where is x? X is equal to log 1 upon y, and dx is equal to, here dx is equal to dy upon minus e to the power minus x, and this is y, so we can write it minus y. So you can write it dy upon minus y. Simple. Here no any problem. So now we can cancel y with y, and this minus will reverse the limit of integration, because we know that 0 to something a to b, fx dx is equal to b to a, here minus will come fx dx. This is a basic property we have been studying since childhood. Okay, so we will use this property and we will put minus outside the integration and we will get the desired result, that is 0 to 1, and y got cancelled with y, log 1 upon y, and x to the power n minus 1. So log 1 upon y to the power n minus 1, and here we can write log 1 upon y n minus 1, and this is dy. So this was our very simple derivation just on the basics of the substitution of integration. So we derived the two properties of gamma function, and you might see this property into the examination. Okay, so must learn it, and we understood its importance and the question based on it. So simply we will see one question based on this property, and after that we will end this. Simple this question. Okay, you can also change the variable, so variable doesn't uh, change the question. Okay, so we can easily write 1 upon y dy, no matter. So our first intention is to check the limit is matching or not. So 0 to 1 and 0 to 1, both gamma functions are equal, this equals this, that means this is also another definition of gamma function. Okay, so whenever question will be given on this basis, so we can simply compare it. Okay, so what we'll see here, that limit is matching 0 to 1, so simply we'll find n and log 1 upon x, so this is as usual, and x dx no problem, y dy no problem, m dm no problem, but must clear it that this might not happen, x and dy, no, this will be wrong. So here x and dx, this is right, so we will just simply compare the value of n. So I told you already how to reduce it in this form 7. How can you write 7 into n minus 1 form? So simply you can do plus 1 minus 1, so the n is equal to 8. Simple. So we know that the gamma 8 is equal to 0 to 1 log 1 upon x to the power 7 dx. So this was the basic concept. Now two properties are finished and one more in the first lecture, recurrence relation. So now we will study the relation between beta and gamma function, then we will solve the questions based on it. So thank you for staying so long. I hope you enjoyed it.